Hey guys, we're gonna jump into 1.3, um, and here we're gonna talk about cross sections of 3D objects. Okay. Um, so first, let's define what a cross section is. So if you see like these solids that we have, so we have like this prism, these prisms, these cubes, or these cubes, I guess you could say. And let's imagine that we have a plane or like something slim like a paper that cuts through it. A cross section is the intersection So cross section is the intersection of the plane and the solid. Okay, so the intersection of the plane and the solid. So you see in these figures that the cross section is specifically colored out as this purple region right here. So it's just where the plane and the solid intersect. So there's a cross section there, and you can see that this cross section is a square. For this one, because it's diagonally cut, this cross section is a rectangle, and then here you can barely see that small intersection because the plane is cutting at one of the corners, and it makes a triangle. Okay, so for these examples here, let's describe the shape formed by the intersection of the plane and the solid. That's what we're looking to do. So we're trying to just identify the shape of the cross section, pretty much. So right here we have this plane, and this right here is 1, 2, 3, 4, 5, 6. So that's a hexagon right there. So a hexagonal prism, and the area is going to likewise be a hexagon. Okay, so that's the cross section there. The cross section here, so to me that looks like it's going to be a triangle. Here, so this is a cylinder being cut by the plane. Okay, so I'm going to just outline the cross section right there, and you can see that it's going to be a rectangle. For D, that's going to be a circle. For E, likewise, this should also be a circle. And for F right there, so outlining this one, that one looks like it's going to be a trapezoid. Okay, so just the thing here is just we're identifying the shape of the cross section. Okay, and in this example here, we're going to draw the cross section. So it says draw the cross section formed by a plane parallel to the base. Now this is the base right here. So here is the base right there. Okay, and we're going to draw a line. So draw a cross section formed by a plane that is parallel with the base that intersects with the red line segment drawn on the square pyramid. Okay, and what shape does it make? So imagine that we're taking just like a slice of paper and we're cutting it through right there. Okay, so if we do that, see if we can accurately draw what that would look like. Okay. So the thing is, so just explaining my thinking. So the plane has to be parallel with the base. So that means at this intersection right here. So basically, if we have a line right here, the plane has to be parallel. So it has to cut through right there. Okay. And it has to cut through right there. and right here. Okay, so I'll highlight that area of the cross section. So the cross section has to be like this. So this one's not too bad to draw because I knew that the lines had to be parallel, right? So it wasn't too bad. It was actually kind of an easy draw. And if I take away these extra lines, because I know it can get kind of complicated, it might be easier to see that intersection right there. So the shape of that intersection, I believe, I can't really tell if the side lengths are congruent or not, but well, it does say it's a square pyramid right there. So this is a square, so it must follow that this is also a square since it's parallel. So yeah, so this would be a square. The cross section would be a square. Okay. Now you can go through these problems right here. Again, identify the intersection for these ones, like the shape of the intersection, and then you can draw the intersections here. Well, I think you guys can do these ones. I can at least show you how to draw something like right here. So the plane is perpendicular to the base, so this is the base right here, the pentagon, and so we want to draw the cross section formed by this line. Okay, so the intersections are right here. Okay, so I think it should cut down like that. And I'm going to draw a line that's parallel with this line right here. And move that down here. Yeah, so it has to connect right there. Okay. And then it will cut through that line right there. So here is that right there. I'm not sure if it helps. I'll try and make it dashed or something like that. Okay, so it's going to cut through right there. So the intersection, I believe that looks like it's just going to be a rectangle right there for that one. That will be the cross section. Okay. Go ahead and try the rest of these though. Example 3. So here are some story problems. So it says that a machine at a sawmill cuts a 4-inch by 4-inch piece of wood lengthwise across its diagonal, as shown. So they're cutting it across here. Find the perimeter and area of the cross section formed by the cut. Excuse me. So we know it's a 4-inch by 4-inch piece of wood, but they're cutting along right here. Okay. So they're cutting along right there. So they're cutting this wood into 2 parts, and you can see that's going to be like a triangle right there. So you see the triangle. So we want the perimeter of this piece of wood right here. We want the perimeter of where it's being cut. The perimeter and the area. Okay, so first thing we need to find this length right here. So because it's a 4x4 piece of wood, and that this is a that means that this wood, when it's cut, is a right triangle. So these are right angles right here, and so a 4x4, since this is a right triangle, if you guys remember, as we learned back in chapter 9, that this creates a special triangle, so the side lengths are the same, and so because of that, we know that this length right here is a so it's a 45 45 90 triangle, and a 45 45 90 triangle has the ratios of 1 1 and square root of 2. So the hypotenuse is square root of 2 times larger than the legs. So I know that this side length right here has to be 4 times the square root of 2. So that's the length of that. You could also use the Pythagorean theorem and you can get the same thing to find the hypotenuse. Okay. Okay, so this is in inches, right? So what I'm trying to get is the perimeter. So I need to add up this side right here with this side, which are congruent, and this side, which will be congruent. Now, the only problem here is that we're measuring in inches, but this is in feet, so we actually need to convert this to inches. So 8.5 feet in inches. So since there's 12 inches to a foot, we need to multiply that by 12. So we need to do 8.5, multiply that by 12, and so this is about 102 inches. Okay, so now we're in the same units, and so to find the perimeter, just need to take the sum of all the sides. So it's going to be 2 times 4 square root of 2 plus 2 times 102, because there's two lengths, 2 of both sides. So that's equivalent to 8 square root of 2 plus 104. Oops. Okay. I think it just crashed on me. And didn't really keep any of my work. Okay. Sorry about that. So the perimeter is so 2 times 4 square root of 2 plus 2 times 102. Okay, and so like I said, so that's going to be 8 square root of 2 plus 204. And so I'm just performing the calculations right now in my calculator, and when I add that up, I get 215.31 inches. So that's the perimeter of this cross section. Now the area of the cross section is just going to be the length times the width, so that's going to be 102 times by 4 square root of 2. So 102 times by 4 square root of 2. Okay, and I'm getting about 577 inches squared. Okay, not too bad. Go ahead and see if you can try number 7. It's just using a pi. Just pretty much you're just doing the same thing. You're trying to find the perimeter and the area of the cross sections when you cut a piece of pie. Okay, but yeah, that does it for 1.3, and again we're doing 1.3 and 1.4 in one go, so go ahead and jump over there for your pretty much just the last video of the year. So